So this is the second major learning concept in Unit 5. The first learning concept was how do we simplify rational expressions, and we worked with adding and subtracting and multiplying and dividing and factoring those expressions to simplify them. This is the second major concept, and it's how do we solve rational equations. So remember the difference between an expression and an equation. Equations have a variable we're solving for. So we're going to get an end answer like x equals 2 or y equals 3. Rational means we have fractions involved. So we're solving equations that involve fractions. So here's an example of what an irrational equation looks like. So it's two expressions that are set equal to one another, and then we are solving for a variable. Now, how can we do this? So this is like the detailed. We first find the LCM, and then we clear the denominators, and we solve the polynomial equation on top, and then we always check for extraneous solutions. Now, we learned what extraneous solutions were in Unit 2, the quadratic unit, last semester. Extraneous solutions mean you do all of the work, but when you go back to the original problem, you realize that that specific answer won't work. For solving rational equations, where we find extraneous solutions occur by looking at the denominator. Remember, you never can have a number over 0. This gives you an undefined answer. You never can have a number over 0. So if x was 0, we'd have a problem because I can't have x over 0. Or if I solved this equation and I got an answer of x equals -3, that won't work. Doesn't mean I did the math wrong, but if I plug in -3 plus 3 is 0, and you can't have 0 in the bottom. Over here, if I did all of the work and I got an answer of -1, that wouldn't work because, again, I would end up with 0 on the bottom. And lastly, over here, if I got an answer of 0, again, it would not work because 0 cubed plus 2 times 0 would be 0, and I would be in trouble. So what this is saying again is we're going to find a common denominator using the idea of LCMs, least common multiples. And after we find a common denominator for both, we are going to clear the denominators. That means we're literally going to cross them out, and we're only going to solve the top. And the top will be some type of a polynomial. And we're going to solve using the methods we've already learned in class. And then when we get a final answer, we always have to go back and say, would it be an extraneous solution? And we can find that out by looking, do the answers that we receive, whether they're 1, 2, 3 answers, when you plug them in, would it make the denominator equal to 0? All right, we're going to get started with the first problem. Please make sure, as I've stated earlier in this unit, please make sure to number every example. This is example number 1. All right, so let's think about what would be the LCM. What is the least common multiple? Well, this is not just a 3. These go together like a couple. This is an x plus 3. So the LCM is x plus 3. Now when I look at 6 and 18, I'm going to put that off to the side. And if I asked you, what is the LCM of 6 and 18? You can identify the LCM of these two numbers by writing out the multiples. 6, 12, 18, 24, multiples of 18, 18, 36. And the smallest number that occurs in both lists will be the LCM of these particular numbers. So the LCM of these three different terms, x plus 3, this group, 6 and 18, is 18x plus 3. How does that help us in solving this? When I look back to the three parts here, and I look, okay, this is the LCM, I'm going to cover up what they already have. They both already have an x plus 3. So this is missing an 18. So in reality, I need 18 here and 18 on top. Whatever you do to the bottom, you must also do to the top. When I look at this middle term, and I go, okay, I only have a 6. Well, first it has to bump up to an 18, and it's only ever going to bump up by multiplying or dividing. So how do I get from a 6 to an 18? I'm going to multiply by 3. So now I have the 18, but I'm still missing the x plus 3. X plus 3 and x plus 3. My final term in this equation, I cover up the 18, I cover up the 18, I can see it's missing an x plus 3. Whatever you multiply by the bottom, you must also multiply by on the top to keep the equation balanced. So I have 18x plus 3, 18x plus 3, 18x plus 3. What have I just done? I've just determined the LCM of the denominators, and now I'm going to clear the denominators. So literally what I'm going to do is I'm now going to cross out the denominators and write down what I have on top. So 18 times 4, I know that is 72. If you didn't know, we could flip to, if you didn't know this, what we could do is we could go over to Desmos. Remember, Desmos is also a calculator, and I could take 18, and I'd come down here. I think I said times 2, but I meant to say times 4. And 18, oops, excuse me. And to show you, 18 times 4 is an answer of 72. Remember, this is a calculator as well, not just a graphing device. So 18 times 4 is 72. Then I have 5 times 3 is 15 times the quantity x plus 3. And I have 23 times the quantity x plus 3. So right now, I've found the LCM, I've cleared the denominators, and now I'm going to solve the resulting polynomial equation. Well, what do we do here? Well, we're going to start by doing the natural. We're going to distribute. 72 plus 15x plus 45 equals 23x plus 9 plus 69. And I'm going to move the x's to one side and the constants to the other side. What does that give me? 8x I can do these quickly on a calculator. 72, 45, and 69. Is 48. This is not official yet. Remember, extraneous solutions, so I have now solved the resulting equation. Extraneous solutions mean you did all the math right, but when you go back to the original equation, before you've changed anything, we need to make sure that this doesn't somehow create a 0 in the denominator. Well, there's no variable that was originally here, so it can't create a 0. There's no variable here, so it can't create a 0, but here we have a variable. When I take 6 and I substitute it in for x, 6 plus 3 is 9. That's not 0. That means this is the official answer. If I would take 6 and plug it in here, and I would take 4 over 9 plus 5 over 6, we'd get an answer of 23 over 18. All right, so I'm looking on my phone right now, and I would like you to give me a rating of 1 through 5 and how well you understood that problem. 1 through 5, please. Again, I'm looking on my phone. I'm looking for the 1 through 5 on your feedback. If you happen to give yourself a 5, I would like you to begin this problem on your own. Anything below a 5, I want you to continue to work with me on. Okay, so I'm going to write the steps off to the side. We're going to figure out the LCM. We're going to clear the denominator. We're going to solve, and we're going to check for extraneous solutions. Now I'm going to go back to that last problem. And I want to just say, hey, we didn't get this as an answer. We got an answer of -3. What if that was the case? This is not true, but what if that was the case? And when I looked into the denominator and I plugged in a -3, I could see that the denominator was 0. What would I say was the answer then? Is -3 the answer, or isn't it? No, this is an example of an extraneous solution, which means if there's no other answers, we would say there is no solution. I'm just giving you an example. We don't include extraneous solutions as your final answer. Okay, so I'm going to start by finding the LCM, just like example number 1. So the LCM of this problem, I know I have an x plus 3, and I'm looking at 2 and 10. 2 and 10. Now what is the LCM of 2 and 10? So 2, 4, 6, 8, 10. That's for 2 multiples of 2, 10, 20. I can see the smallest number in both lists is 10. Coming back up to the original problem, I have an x plus 3, great, but I still need a 10. So I attach a 10 to the bottom and a 10 to top. In the second term, I have a 2. Now, some students in the past have said, well, can't I add 8 to bring out to 10? You can only multiply and divide. So we are going to multiply by 5 to get up to 10. Now I have a 10 both on the bottom and a 10 on top. What I'm missing is an x plus 3. Finally, the last term, I cover up the 10. I can see I'm missing an x plus 3. And I want to go back before I start anything to make sure that I've covered all the bases. 10x plus 3, 10x plus 3, 10x plus 3. So I've identified the LCM and I've covered finding a common denominator. Done. I'm clearing the denominator and now I get to solve the top. 10 times 2 is 20. 3 times 5 is 15 with an x plus 3 equals 19, x plus 3. And 45, simple math I can do here. Is this an extraneous solution? And again, I know I'm going through this fairly quickly, so know that when I'm done explaining this problem, I will leave it up here for you to continue writing. You only look at the denominators. There's no variable here in the denominator of the original problem. There's no variable, so I get to skip it. There's no variable, I get to skip it. This has a variable. When I substitute in 2, the only thing we're looking for is, does the denominator equal 0? And when you substitute in 2, you get an answer of 5, which means this is not an extraneous solution. This is your final answer. What does that mean? It means if you plugged in 2, you'd have 2 over 5 plus 3 over 2, and if we put that into a calculator, we'd get an answer of 19 over 10. I'll give you a chance to continue writing before we move on to example number 3. Okay, I'm going on right now to example number 3. What looks different about example number 3? Well, it looks like I need to do some factoring on the top and maybe on the bottom. And now I have variables on top, which I did not have in example 1 or example 2. Find the LCM, clear the denominator, solve, and then check for extraneous solutions. Okay, let's start with the LCM. So this is x plus 5, and I need to factor this. What multiplies to equal 15 and combines to give you 8? What multiplies to equal positive 15 and combines to equal 8? That would be 3 and 5, x plus 3 and x plus 5. What's nice about this is that the leading coefficient is a 1. I don't have to worry about bottoms up. So okay, I've broken apart the 3 different terms here. And now to determine the LCM has to have an x plus 5 and it needs to have an x plus 3. So I cover this up, and I cover this up, and I ask myself, what is the first term missing? It's missing an x plus 3. X plus 3, x plus 5, this is missing nothing. X plus 3, it's missing an x plus 5. I found the LCM. Now I get to clear the denominator, and now I get to solve. Okay, this is tricky. See how there's a negative outside that has to apply to all of this? I'm going to put it in parentheses so it's not forgotten. Distribute 2x squared plus 6x. Everything, when it gets multiplied by the negative sign out front, is going to change signs. I'm going to move everything over to the left-hand side. Now, why am I moving everything over to the left-hand side when in the previous problem I didn't do that? Well, the previous problems only had a single x. There was no x squared involved. It was not a quadratic equation. When I move it across, it's going to change signs. So it was positive to move across becomes negative. It was positive to move across becomes negative. And now I'm going to combine like terms on the left-hand side. All right, positive 2x squared and negative 1x squared is a 1x squared. 6 and 1 is 7. 7 minus 3 is 4. Negative 15 and 10 is negative 5. Let's do just a quick review. How can we solve quadratic equations? Well, I'm going to write down our steps. I always try factoring if it's possible because it's the quickest way. Then we have the quadratic formula, or we have the completing the square method. Okay, so is this possible? 1 times negative 5 is negative 5. And are there two numbers that multiply to equal negative 5 and combine to equal positive 4? Get a quick drink of water. Hold on. Thank you. That's going to be a positive 5 and a negative 1. Multiply and combine. We can see how important it is that we've learned factoring. X plus 5 and x minus 1. Okay, so I've factored it. The leading coefficient is 1. I don't have to worry about bottoms up. And if you've forgotten now, what's opposite of this? X equals negative 5. What's opposite of this? X equals positive 1. Technically, we arrived at those answers by setting this parenthesis equal to 0 and solving, and setting this parenthesis equal to 0 and solving. Now we're going to go on to step number 4. What is the extraneous solution? So I have to go back to the original before I've added anything or attached anything to the denominators. Let's start with a positive 1. Let's start with a positive 1. This has a variable, so I check it. When I plug in positive 1, 1 plus 3 is 4, not 0. Don't worry about anything that's attached. We're only looking at the original. When I plug in a positive 1, notice that this trinomial is equivalent to the factored form. So when I plug in positive 1, this is 4, not 0. When I plug in 1, this is 6, not 1. I'm good. When I plug in 1, this is 6. That means that I know for sure x equals 1 is an answer. Okay, let's try it. Negative 5. It has a variable in the denominator, so I check it. Plug in negative 5. Nope, it's not 0. But when you plug in negative 5 to this part, we end up with 0. If any part of this is 0, automatically we identify this as an extraneous solution and we don't consider it. So what would we say is the answer? The answer to this rational equation is only x equals 1. I'll give you a little more time to write it down before we go on to example number 4. Can you please do me a favor right now? And can I have you give me a 1 through 5 on your understanding right now? 1 through 5. Thank you for participating. So you're going to label this right now. This is example number 4. Example number 4. Now this only looks slightly different. In fact, this problem is much like examples 1 and 2. It's much like 1 and 2 and less like example 3. What confuses students when they look at this is they're like, there's something missing. I don't see a denominator here. Think of this. What's the only number you could put underneath your current age, and when you divide those two numerical values, you still get the answer of your current age? So I'm 40. The only number I can take and divide 40 by this number and still get 40 is 1. So when you don't see a number at the bottom, it's a hidden 1, and you want to put a 1 in that place. If you scored yourself as a 4 or a 5, I'm going to let you have a 30-second head start before I begin. One and 6. Multiples of 1 would be 1, 2, 3, 4, 5, 6. Multiples of 6, 6 and 12. The first number in each list is a 6. So what is this missing? It is missing a 6. What is this missing? 1 times 6 is 6, and it's also missing a y minus 2. This has a 6, it's missing a y minus 2. And I do want to go back and check everything. 6y minus 2, 6y minus 2, 6y minus 2. Remember, whatever you attach to the bottom, you must also attach to the top of that same fraction to keep the value of the fraction the same. So I get to now clear out the bottoms, and I only have to solve the top. 30 plus 12 times y minus 2 equals 17 times y minus 2. And now you can see that this looks much like example 1 and 2. So 30 minus 24 is 6. 30 minus 24 is 6. 6 plus 34 is 40. Oh, this isn't a, I think I wrote something down wrong there. Oh, but maybe it looks right. So I have 8 equals y. 8 equals y, and now I need to check, is that an extraneous solution? So sometimes the confusion for students is, do I check the bottom, do I check the top, is it the original or when I've attached things? It's the original problem that we can see right now in a bold black color. And we only look at the denominators, and if there's not a variable that's in that original denominator, we get to bypass it. No variable, bypass. No variable, bypass. This has a variable. When I substitute in a value of 8, 8 minus 2 is 6, it's not 0. That means this is the final answer. Example number 4 is going to remind you a little more of example number 3. I'm sorry, this is example, my apologies. This is example 5. It's going to remind you of example 3. So if you felt pretty good about example 3 right now when you look at your notes, I'm going to give you a 30-second head start, and let's see what you can do with this problem. I will begin in 30 seconds. Sometimes students get confused with different variables. Feel free to change it back to an x if that makes you feel more comfortable. This breaks into z plus 1 and z minus 1. Z plus 1 and z minus 1. So my LCM is z plus 1 and z minus 1. The left-hand side, when I cover it up, I can see it's missing a z minus 1. The middle is missing a z plus 1. And this has both a z plus 1 and a z minus 1. So I've taken care of the LCM. Now I'm going to cancel out the denominators, and I'm going to write down what I have. I have 2 times the quantity, z minus 1. Subtract 1 times the quantity, z plus 1 equals negative 2. And this is similar in the fact that we don't have a quadratic equation we're solving for. So 2z minus 1z, when I combine like terms, is 1z, and negative 2 and negative 1 is a negative 3. Stay awake, don't fall asleep. I get an answer of 1. Can I have you go into the chat? Did anybody else, before we check for extraneous solutions, did anybody else get an answer of 1? Anybody else? Looking for your answers? Yes? Okay, so I'm going to take this and I'm going to check for extraneous solutions. This has a variable I check. So when I plug in 1 here, 1 plus 1, when I substitute it in, is 2. Nope. 1 minus 1 is 0. Some students say, does it have to be 0 for everyone? No. As soon as you find one parenthesis or one factor that's equivalent to 0, we stop. We say this is extraneous solution. Well, what else is there? If this is an extraneous solution, what else is there? There's no other answers, so we have to write no solution. There is nothing else. Going on right now to example number 6. We don't have very many left over. 2 left. I'm going to give you a chance to write it down first. I'd like you to try this one. You're going to get a fractional answer, and that's okay. This would be Remember when you attach something to make sure it goes in parentheses. So I've found the LCM, checking everything is there, everything is present. Okay, I cancel out the denominators, and now I solve the top. Okay, can I have a yes or no if you received the same answer that I did? Yes or no, please, if you have the same answer that I did. Looking for answers. So how do we check this? Well, remember that when it's in this form, factored form, it's really easy to check to see what the answer is. It's opposite of this. So 2, this is not the same as 2, so it won't make it equal to 0. This isn't the same as -4. This isn't the same as 2. This isn't the same as -4. This isn't the same as 2 or -4, which means that this is the correct answer. That was example number 6. I'm going to give you a little more challenging problem for example number 7. It is our last one of the day. And I'm going to give you 2 minutes to see what you're able to achieve. If you're a little confused where to start, feel free to look up here. If I remember from previous years, students were able to understand after I gave a helpful hint about factoring, they were able to understand the factors of n-1 and n+1, but when they see the coefficients of 3, 4, and 2, how do you determine the LCM? So I listed the multiples of 3, multiples of 4, and multiples of 2, and the smallest number that pops up in all 3 categories is 12. So n-1, n+1, and this needs to be a 12. So 3 times 4 is 12. This needs to be a 12 times 3. We have an n-1, it needs an n+1. It needs to be a 12. Can somebody unmute themselves if you'd like me? I'm going to go step by step since this is the most difficult problem today. Would anybody like me to re-explain how I achieved the LCM and when I was able to identify the common denominators for each? Would anybody like me to do that? Anybody? Okay, so I'm going to bypass now step 1. So I've identified the LCM and I've achieved that with each term in the equation. Now I get to cancel out the denominators and I only have to worry about the numerators. So I've distributed through, and now I'm going to combine like terms. I see that I have squared, so we have a quadratic equation. It appears, so I'm going to move everything to the same side. So now on the left side, I'm looking at 1, 2, 3, 4, 5, 6. These 6 terms I'm going to combine like terms with. Negative 28 and positive 18. Negative 28 and positive 18, and then minus 15. That's a negative 25, but let's look and see. So if I pop up here, remember I can use this as a calculator. So I come in here, and again I'd have negative 28, positive 18, and negative 15, and it is a negative 25. How do we solve that? Remember, we have factoring, quadratic formula, or completing the square. Well, I can see all of these are divisible by 5, so I'm going to pop a 5 out, and I'd have 2n squared minus 5n minus 3. Now, I always choose to try to solve using factoring first because I think it's just a little bit easier method. So I'm going to see, is this trinomial factorable? Do I know two numbers that multiply to equal negative 6 and combine to equal negative 5? I do. Negative 6 and positive 1. Multiply and combine. So I should put an n, not an x. And minus 6 and n plus 1. Don't forget the leading coefficient is different than 2. Or is different than 1. It's a 2. This reduces to an n minus 3. And then I have an n plus 1. Yes, if I was factoring, I would push this back up. But we're trying to solve. And that's why I like the factoring method, because I can easily solve to see one answer is 3, and one answer is negative 1/2. One answer is 3, and one answer is negative 1/2. Okay? So I'm going to come back up here again. And I'm going to look after I've factored here. So if I plug in 3, I'm good. If I plug in 3, I'd be good. It's not equal to 0. If I plug in 3, it's not equal to 0. How do I know that? 3 plus 1 is 4. 4 times 3, not 0. 3 minus 1 is 2. 2 times 4, not 0. And 3 plus 1 is 4. 4 times 2, not 0. Now, negative 1/2. I know that negative 1/2 plus 1 is not 0. And if I take a value that's not 0 times 3, it's not equaling 0. I know that a negative 1/2 minus 1 is not 0. And if I take that times 4, it's not 0. Again, and then negative 1/2 plus 1 is not 0. Taken times 2 is not 0. That means both of these happens to be the answers for this quadratic equation.